Hey, what's going on, guys? GoMakeGains here. So in this video we'll start and hopefully finish implementing a function to parse the FEN string as an input and to set the board position respectively. So a very quick information on what the FEN string is for those of you who is not aware of that. For those of you who is aware of what is that, it's almost exactly the same as in Western chess. So ranks are divided by slash symbols. The leftmost rank is the uppermost rank on the chessboard. So this is kind of in CNC, this is rank 10 or 9 depending on indexing. So this is the highest rank. So let's say this rank represents pieces being put here. So you see, like this rook, knight, bishop, the letters are exactly the same. Then we have 9 spaces, 9 empty squares, which we have exactly. Or oh, hold on a sec, I've made a horrible mistake here. So the diagram is wrong. Oh, this is a little bit unfortunate. So I just need to fix this. So, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, so let's make it like this. I'm extremely sorry for this inaccuracy, guys. Yeah, obviously. So yeah, we have this 9 empty squares, then 1 empty square, cannon, 5 empty squares, cannon, 1 empty square. So this is what we have: 1 empty square, cannon, 5 empty squares, cannon, 1 empty square, and so on. So lowercase letters represent black pieces, and uppercase letters represent red or white pieces. Side to move might be either W, which stands for white, which is the standard FEN notation, but some implementations are using R, which stands for red. But we would be we'll make it easy to, we'll make it flexible to handle both cases. In Western chess, this is the castling and in peasant square. They are not present in CNC. This is the half move rule counter in regards to 50 rule move draw. In case of CNC, this is 60 rule move draw, if I'm not mistaken. And this is the full game, full move counter during the game. So how many moves we have there. So first, in this video, we'll implement the part that keeps track of this part. I don't know. Well, probably if you see, well, this 50 or 60 rule move as well. Well, we can actually. I mean, this full move rule counter, I don't even remember if I was using this ever. Probably I did, but so that's just possible that probably we would be getting back to this setBoard FEN. Okay, just hold on a second, guys. I just want to reference my Western chess version. So nope. Gameplay. Well, still, when we would be making hashing that would be on the card. So 50 gameplay, and hold on a sec. Oh, the gameplay. We don't yet have that variable. The gameplay. Yeah. Okay. Yeah. So this would be parsed later on. Okay. Okay. So I don't know. Okay. I would be reusing the IDEA. So yeah, let's start writing our parse FEN function. Well, we'll call it setBoard FEN. Okay. Without further ado, let's actually go for it. So input and output. So here above. So this here we wanted to print board to console, and here we want to set board position from FEN string. So function setBoard, and we're taking FEN string as an argument here, save. So first we want to reset the board. So whatever was there, we need to reset the board and game state variables like king square, 6 to rule move counter. Okay. Later on there would be the game. No, gameplay. It's been resetted somewhere else, if I'm not mistaken. Yeah, that's by now it doesn't matter. Okay, so the same loop over files and ranks is about to be done. So let's reference our piece of code responsible for that. So here. So we want to parse position. Okay, we don't need this board string here. Okay, and now a little bit tricky thing. Not very tricky, but still. So yeah, we need this index variable to as far as we can't use the pointer directly for strings in JavaScript. We would be using index to mimic that. So index would be pointing to a particular character within the FEN string. So index starts with a 0 pointing here, then index would be 1, 2, 3, 4, 5, 6, etc. Okay, so now we need to make sure that the square is on board. So we can reuse this from, no, in setBoard we don't need this. We can reuse this from printboard. Copy. Hold on a sec, what have I done? What have I done like this? Save. Yeah, and all the logic would be done here. So here we pick up the case if we have three cases to encounter within the FEN string. So I'm not going to be doing any validation. So this engine would be assuming the correct FEN, which might be a little bit weird, but usually chess engine developers not really getting bothered by validating the FENs. So we might have encountered three types of characters during when parsing the position. So the ASCII characters, slashes, and digits. That's kind of it. Very simple. So, and here is the case. So, well, let me just grab this stuff. Yeah, and I would be adjusting this by okay. So paste, save. So what we have, okay, save. So greater equals alpha, less equals. So here we just make sure to pick up the characters. So in this case, so yeah, kin, we want to initialize the kin square, which is correct. So kin square has the same. Not white but red in this case, and here it would be black respectively. Yeah, then I would need to add a couple of lines to printboard function to make sure that the kin square has been initialized correctly, to check up everything really. And here initializing the board itself, FEN index by the index plus. Yeah, so we're just taking the board square, whatever square we have, while we only looking for those squares that are on board, And then we're using this character, whatever character we encounter within the FEN string, so whatever of these guys, we use it in order to index, where is that? In order to index array character pieces. Yeah, I didn't yet create this, so I will now do this, and indexing this by FEN indexed by the index. So whatever pointer we have, FEN is a string that we're taking as an argument. So respectively, so this character pieces, this would be an object, right? If I'm not mistaken, this should be an object piece. Or hold on a sec. Yeah, an object, obviously. So yeah, I think I can reuse this as well. Copy. So promoted are not used at the moment. So here I can also say that we want to so this would be the character piece, ASCII character piece representation, save. And here, well, the order might not be that crucial, but I really want to use this order. In object, this doesn't really matter literally at all, but just to make it a little bit more readable. So for pawn, yeah, and something that would be returning would be a little bit different. So here we would be returning not the character, because it's not encoded like this in this engine, but the white pawn. So just to give you an idea, what am I doing here? So let's say we encounter this big P, which means the white pawn. Actually, hold on a second. Would it be? It's not white. It's actually red. So yeah, I need to rename this to red to be a bit more precise. Copy, paste. It's not crucial, but it's actually red. It's not white. Okay, even though we use the W for, which stands for white in the FEN, but still the pieces are red, and we also use the red color, not the white color. Okay, so let's say we take this big and hold on a second. Yeah, this is white or red. So let's say we take this pawn, and we need to map this to the piece code for red pawn, and this is 1. And this is exactly what we're doing with this object. As far as this is not performance consuming, it doesn't affect the performance, doesn't influence it at all, because parsing FEN is done just once, and that's it. It's not done a million times in a second. So using slow JavaScript objects is literally okay here. So I will probably go for this sort of a way. So red pawn, red advisor, red bishop, now red knight, now red cannon, my favorite piece in CNC, red rook, and red king. Okay, and the same for black pieces. So black pawn. Here we have a black advisor. Here we have the black bishop. Here we have black knight. And here we have black cannon, black rook, and finally black king. Okay, so now this should be working properly. And then what happens? So as soon as we do convert the current given ASCII character represented a certain piece type to internal engine's piece code for this given character, after we're incrementing index by 1. So first, before this, the pointer was pointing here to the first element. Now it's pointing to the second element. Well, it's not actually the pointer that is pointing, but just it's easier for me to explain this in this terms of a low-level languages like C. Okay, yeah, and working with JS is really okay. Sorry, man. Just answer a bit later. It's really I really appreciate you guys that you're so active and giving the commentaries below the videos. This is an absolutely fantastic experience. I'm really happy to have this sort of an interaction with you guys. This is why I'm doing this, basically. Okay, so the next then. So the next is, so here we are dealing with pieces. So parse pieces. Here we want to parse empty squares. So in case if we do encounter this sort of a numbers within the FEN string, we're making this trick of converting to integer, converting this string to integer. It's not obviously should be done like this. I could have used toString as well, probably. That is a little bit more of a JavaScript way. In that case, I don't even need to use this character code at. Yeah, I think that's a little bit of redundancy. So, yeah, I don't even need this. Okay, hold on a sec. Oh, no. Let's better keep it. Let's better keep it because, yeah, let's better keep it as is. I don't want to create extra work that is not necessarily needed. And here is an interesting thing going on. So, so we're calculating the offset for an index, right? Not for an index, for a file. So the idea is to keep track of no, it's not how to explain this. Initially we start with the following scenario. So we have the square here and also the index here, but let's say when we come here, the index is pointing here, and so on, but the square, it kind of goes further on. So we need to correlate between these two values, and that's the reason for this logic. So calculating the offset, so converting whatever number we have within the FEN to integer. This is how it's done. This is the hack from C programming language. And then this extremely important line. So if not, so let's better call it more explicitly clear. Empty. So if we start with an empty square, we need to make sure to decrement the file, otherwise the position just gets shuffled. a little bit, so this is extremely important step to consider. It's a little bit dirty hack, but yeah, but this is fine, it works. So adding the offset to the file and then go into the next element. Okay, and again, like if we just encounter the slash, we also do shifting our index, like incrementing the index. And already we didn't yet parse the site to move, but already this should be, so setBoard FEN should be working. So at the moment we have white rook is not defined, so yeah, that's because here, okay, we don't need this code anymore. So now okay, and setBoard is already the part of parse FEN, is it? Yeah, so we don't need that as well. So now we can simply use only the couple of lines of code. So setBoard and FEN would be this start FEN, and then we just want to print the board, and that's it. If I did everything correctly, it should now print the CNC board. Perfect, we got it, right? So here are the pieces, and we got the CNC board. This is one of my favorite stages or when I develop a chess engine. Yeah, when this parse FEN starts working. So now we need to parse also the site to move, and also to print all the variables we are initializing during the parse FEN routine actually works. So let's get back to here, and we say this is the print board function. So I can say board string plus equals, and I want to print the site to move, and plus, and if site, so let's say site equals to red. In this case I want to print red, and otherwise I want to print black. Save. So now I should print white site to move, but it's not because of parse FEN, this is because it's initialized like that by default. And also the so a little bit, yeah, like this is perfect now. And no, hold on a sec. Also I want to have the new line, and also I want to say board string plus equals kin square and plus coordinates is the kin square, hold on a sec, is the kin square being initialized based on, yeah, both are initialized. So let's print the both. How did I do this? I don't remember. So print board kin square Xiangqi castling moves. Didn't I? Okay, let's have both. So I want coordinates kin square indexed by red, and I want let's make it like this even, plus indexed by black. So let's have a look. Kin square is not okay. Typo. Yes, a little bit misplaced, but okay. So E0, which is correct, and E9, which is correct. Good. So first for red, second for black. Okay, so kin squares, hash key is about to be added later on. I will explore. I'll explain in great details what is that and why the heck do we need that. Really lots of purposes, but for now, okay. Site to move. Yeah, for now this is enough, I believe. But here is the deal. So let's say we turn this to black, so nothing would change because we don't yet parse it at all. It's still it's red. So it was split by spaces. So first element, so this should be the second element. So parse FEN. Well, just to make 100% sure I don't miss anything. Let me grab that part of code. So we need to skip the empty space after the very last character in the position, and then print board. Nope. Here. And then we don't even need this stuff because we're not about, there is no castling or in peasant. So red or black, but as far as this might be not always W but also R, so to avoid any disaster we can distinguish by B. So in case of B this would be black, and otherwise this would be red. Save, and the site would get initialized. So this is it. This is the flexible way of handling site to move in CNC FEN. So now it should be black, yeah, because we've explicitly set that to black. And now if we restore it back to white, save, it should be red. Okay, and if we set this to R, it should be red as well. Well, actually we can set this to whatever letter and it still would be red. So that's a little bit of a downside, but I think that is just fine. Okay, so is this really it? Yes, I guess this is it. Yeah, at least for now this is enough. Well, later on when we would be adding hashing, would be initializing the hash key from scratch, but all that stuff would be added later on. So first we need to obtain a working mode generator, and then would be adding all the bells and whistles to serve to get the full-blown featured CNC engine. Well, okay guys, so this is it from my side. Yeah, it's for now it feels slightly easier compared to Western chess. We'll see how it goes further on. The next stage would be to create the is_tag function, one of the core functions of the mode generator, to make sure that we can know for sure whether the key has been exposed into a check or not. I didn't yet create this function for CNC ever, so I need to work that out a little bit before making a video. Probably, maybe I would even create the entire mode generator and try at least a couple of positions for perf testing to make sure it works, just to come up with a proper architecture for the initial implementation. So yeah, that's kind of the plan. Well, okay guys, so this is it from my side. Thanks for watching. Until the next time, and take care.